This is an introduction to Chapter 6, which shares a lot of similarities with Chapter 2. For instance, in Chapter 2 we looked at sequences, which are basically a list of numbers. Here's one of our favorite ones. And series, which are basically infinite sums, which really correspond to other sequences. And we ask questions. We ask some questions. This was not the main point of these sequences and series. Namely, if a sub n goes to a, we could ask if all the a sub n are positive, then is a positive? The answer is no, because, say, the sequence up above, 1 over n goes to 0. That's ugly, but yeah. How about, right, another question, if a sub n is bigger than or equal to 0, then is a bigger than or equal to 0? The answer is yes, by the order limit theorem. Similarly, like, right, if a sub n is rational, is a rational? Is the limit rational? The answer is no. For instance, 3, 3.1, 3.14, etc., is going to converge to pi. So we can ask these questions that if you know something about the terms of the sequence, what do you know about the limit? Now, Chapter 6, moving on, we're going to look at sequences again, but now we're not going to look at sequences of numbers. We're going to look at sequences of functions. For instance, kind of an analogous sequence would be 1 over n times x, which is equal to the function x, which is, right, a horizontal or a diagonal line at 45 degrees. And you get 1/2 x, 1/3 x, etc., etc. Same thing. So we can look at these sequences, and then we can see if it has a limit. And similarly, we can look at series. Our series are going to look mostly like this, power series. So it's going to look like x plus x squared plus x cubed plus da 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 da. And very similar to over here, the way we deal with infinite series, even if the things here are functions rather than numbers, what we do is we still look at the sequence of partial sums. So we get a whole bunch of kind of nice finite polynomials in this case. And so we can deal with these. And we are going to ask similar questions of these functions. Oh, by the way, the normal notation we'll use is f sub n, and then it might go to f if it converges. Right, so let's suppose f sub n, the sequence of functions f sub n, kind of like this up here, x, 1/2 x, 1/3 x, suppose it converges to a function f. So here are some questions we might ask. If all the f sub n are continuous, is f continuous? Right? Similarly, if all the f sub n are uniformly continuous, is f necessarily uniformly continuous? Similarly, if it's differentiable, is f differentiable? You can ask similar questions, bounded, etc., etc. So very briefly, let's take a look at one of these sequences. So that's not the right one. Here we go. So here I have a sequence. Here's a sequence of 1 over n. See, and it's running through 1 through 50. So it started off, as you could see. You know what, I'm going to split this into 2 screencasts because I'm almost done. I want to say just a little more. But let's just stop right here and you can just admire this for another second, then we'll start up at the same spot.